Good afternoon, everybody. Hi there. I'm Peter Forbrusher, the chair of the Programming Committee, and as chair of the Programming Committee, it's my distinct pleasure to introduce to you our keynote speaker for this afternoon for SMPC 2011, Professor Nina Kraus. Nina Kraus is the Hugh Knowles Chair in Audiology in the Department of Communication Sciences and Disorders at Northwestern University, which is also where Professor Kraus received her PhD degree. Her research has been funded continuously by the National Institutes of Health for the past 20 years, and she has published more than 200 peer-reviewed papers since 1981. So this is a truly impressive research record. But more important than that, it's good to note the truly transformative nature of Professor Kraus's research. She has revolutionized the way that we think about the neural processing of auditory signals and the plasticity of the auditory system. It's common to think that complex signals, like the ones we deal with, like speech and music, require processing at a cortical level. But Professor Kraus and her colleagues have demonstrated that the processing of this information occurs at much lower levels, even at the levels of the auditory brainstem, and that the effects of expertise can be found at such low levels as this. And Ani Patel presented some of this research in his research talk. Of particular interest to this group, of course, is the fact that the effects of musical training can generalize to such basic low-level auditory processing, not just for music, but for speech and other acoustic signals. And so with that, please join me in welcoming the SMPC keynote lecturer for our conference, Professor Nina Kraus.
Well, thank you. Thank you very much. Thank you, all the organizers, for the opportunity to come and to talk to you and to maybe give you some of the enthusiasm that I'm feeling for this field and for some of the work that we've been thinking about. And if Ed can wear a tie, I can wear a skirt. Actually, what I'm not wearing is the most important thing, which is my sneakers. Anyway, I was thinking, as I was checking in last night, Keynote. Keynote. These are words we think about, right? And so you know, thank goodness for Wikipedia. How many of you know why people call it a keynote? So I'm not the only person in the world who didn't know this. So apparently, for a cappella singers, the fellow who plays the note before they start singing is playing the keynote and will set the key that the other singers will then go ahead and sing in. And so I'm hoping that maybe you'll hum along, and maybe you can get an idea of kind of where I'm going. So the topic is cognitive factors and how they shape auditory skills. And the cognitive factor that I'm going to really be focusing on is memory, auditory working memory. And the auditory skill that I'm going to be focusing on is hearing, speech, and noise. So here's my little roadmap. So hearing, speech, and noise, we know that there are some musician advantages. And so I'm going to enumerate them for you. And then I will take some time to talk about our approach for accessing biological signals, biological responses from human beings. From there, I really, the essence of the tune really is it's about memory and about the fact that there is a musician advantage for auditory working memory. And I'd like to present the idea that it really is a driving force, that memory is a driving force that shapes our nervous system. I'll finish up with some theoretical considerations and just give you an idea of some of the ongoing projects that we're working on. So the auditory system. The auditory system is great, big, and beautiful. And it involves not only the classic auditory pathway, what we think of as the auditory pathway, you know, that connects we have the pathway that connects our ears to our brain, but also these top-down pathways, these corticofugal pathways that modulate the information that we receive all the way out to our ears. And importantly, there are other networks outside of the auditory system, although they're part of the auditory system. They're not outside. Our limbic system, our memory, our attention systems, we know that there are pathways, there are neuroanatomical links, and that these systems function in an integrated manner. So when we think about the auditory system, we really have to think about the entire brain and the way in which these different processes really interact to make us hear. So this is a convergence then of many levels of processing, as Ani brought out in his opera hypothesis, and in particular this A in opera, the attention. You have to be able to know what to pay attention to in the first place if you're going to remember it, if you're going to do anything with the sound. And so, you know, personal example, just the other night I was working on trying to play something that Dire Straits play, and my husband, who's a musician, came over and kind of played back some of the soundtrack and pointed out some things that were in the soundtrack that I was deaf to. I didn't even know those things existed. So I couldn't even begin to pay attention to them because I needed to know they were there so that then I could engage my attention and move on from there. So this attention process is a great big deal. So music then is a biological influence which transforms sound processing in the brain, and Ani has called music a transformative technology of the mind, and I think that's right. So hearing, speech, and noise then. Hearing, speech, and noise, so you see a stadium. Hearing, speech, and noise is difficult for everybody, and it's particularly difficult for certain populations. So if you're a poor reader, turns out that dyslexic kids, many of them, really have difficulty in noisy classrooms inordinately as we get older. Hearing, speech, in noise it just gets worse and worse. And it is really one of the most common complaints of an older person. Children on the autism spectrum have noise exclusion difficulties. And of course, if you actually have a hearing impairment, that's going to pose some problems for hearing in noise. And we know, even with hearing impairment, that the hearing aid doesn't fix things. It's not just, I mean, it certainly helps, but it will not solve the problem because it is not just a signal issue. It is how the nervous system will interact with that signal and use it. So hearing and noise is a very complex auditory task that involves sensory and cognitive factors, signal factors. So in particular, there's beautiful research that has outlined that there are certain components in the signal that are particularly important for hearing, speech, and noise. If you manipulate them, then these are the elements of sound that will make sounds either perceptually vulnerable or perceptually salient. So the fundamental frequency, certain aspects of the harmonics in sound. And cognitive factors very much will affect someone's ability to be successful in hearing, speech, and noise. So here we have some musicians, and these people are singing. And one of the things that we do as musicians is we pick out certain sounds out of a complex soundscape. So whether it's the sound of your own instrument, or a harmony or a melody line, we need, I mean, part of the training is to pick out the relevant elements of sound, and that's not unlike listening for your friend's voice in a noisy restaurant. One of the ways that we look at how good people are at hearing speech and noise is we use standardized tests. So these are standardized measures of hearing, speech, and noise that have been developed by others, and they are well normed. And so let me give you some examples. If you listen to this, participants are asked to repeat back sentences. So tell me the sentence you hear. So if you haven't heard this sentence before, could you hear the sentence? Okay. Yeah. Good for you. So here's the same sentence.
Sugar is very sweet.
Okay. So these are the kinds of stimuli and the kinds of tests that our participants undergo, because it simulates. We're really interested not in. I mean, yes, we do all kinds of psychophysical tasks, but ultimately we really want to know how are people using these auditory skills in as much of a ecologically valid manner as possible. Also in our approach, we are looking at the effects of musical experience on the nervous system across the age span. And so you see these little icons. Whenever you see, this little guy, you'll know that I'm going to be showing data from toddlers. So, throughout this talk, I'm going to be showing you various bits of data, and the icon up on the upper, upper right, is going to tell you which subject group that I'm extracting the data from. Okay, so here's the little guy. This is school-age kids. And what we have found is that school-age kids are just better on these standardized measures of hearing, speech, and noise than non-musicians. So these are kids who are not getting musical training, and these kids are matched in every other possible way that we can think of. The effects are not subtle, and interestingly, the effects grow with the extent of musical experience. So the more years that they are engaged in taking lessons and in actively practicing their instrument, the better their hearing and noise ability. We see the same effect. We see it across the lifespan where we have tested so far. So these are young adults, and so to be a musician in our study, you need to have begun your musical training before or at the age of 9. And you need to still be actively engaged in playing or practicing an instrument a minimum of 3 times a week. So, we have some professional musicians, but mostly these are people who are not professional musicians at all, but they are just, music is a big, steady part of their lives. Again, in our young adults, we find that the years of musical training is something that is related to how good speech and noise perception is. So the more you play, the better that ability. And interestingly, I think this is something that maintains as we get older. So these are older adults now, and again, we see the same advantage. We see the same, and these are not subtle effects. This is about a 40% advantage. And we see that the same advantage that we see in young adults is maintained in the older